Okay, we are back. We are back with a bang, hopefully. Now, what we want to do is tackle the last of our operations. We've been cruising with binary arithmetic. We've looked at three of our operations. Remember, the number of combinations C is given by 2 to the n, where the n actually represents the what? The number of bits. So since we're going to be multiplying 2 bits at a time, our number of combinations is going to be what? I.e. for 2 bits it's equal to 2 to the 2, which is equal to 4 combinations, and then that is the count 0 what? That will be the count 0, 1, 2, and 3. Those are what? Those are our 4 combinations. So remember that count is in decimal, so let's say our decimal count is 0, 1, 2, and 3, and we know that we have to have what? The equivalent out of 2 bits, so it is 0 and 0, it is 0 and 1, it is 1 and 0 and 1 and 1. I don't know if I've said if I've said just now that we're doing what? We're doing multiplication. I actually, if I did, sorry, I meant that we're doing what? Division for a change. We're doing binary division. We've done our multiplication already, so this is what? This is division. Okay, we are doing our binary division, so we will have the divide sign, and we should know by now 0 divided by 0 is equal to infinite. 0 divided by 1 is equal to 0. Divide by 0 is unheard of, infinite, and 1 divided by 1 is obviously 1. Alright, let's first understand this. What do we mean 0 divided by 0 is 0? Alright, let's first start with 6 divided by 3. If we have 6, 1, 2, 3, 1, 2, 3, which is 6. If we say divide by 3, we mean take away 3. We take 1, 2, 3. We take 3 one time. We take 3. We're able to take 3 how many times? 2 times. So 6 divided by 3 is equal to 2. So now if we did the same and said 1, 2, 3, 4, 5, 6, but we say divide by 2 this time, we say, see how many times you can take 2? 1. How many times can you take 2? That's the second time. We've taken everything and we took it 3 times. So therefore 6 divided by what you call by 2 would be 3. So all that divide means is take away. If you divide a number by another number, you're actually taking away the number you're dividing by. The divider, you are taking it away from the what? From the dividend, and you see how many times you've done that. That is what? That will be your answer. That will be your answer, your quotient for the division. Now let's take another example. Let's take 10. We say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we want to divide 10, let's say, by 2. Each time we're going to take what? We're going to take 2, we count 1, we take 2 again, we count 2, we take 2 again, we count 3, we take 2 again, we count 4, we take 2 again, and we count 5. So if we're able to do what? So 10 divided by what? By 2 will give us 5. Now let's take the same 10 and say, okay, we divide by 3. We say 1, 2, 3, we take 1. 1, 2, 3, we manage to take 2. 1, 2, 3, we take 3. Now we could not find another set of 3, so 10 divided by 3 is equal to 3. with 1 left out of that 3. I could not find 3, so there's only 1 left. So essentially dividing is taking and seeing how many times we've taken. So let's go back to divide by 0. Let's say we take our 10. Let's say we take our 10. Now I will go to 10 and I will take nothing. I took nothing. Okay. We go to 10 and I will take nothing. I'll go to 10 and I will take nothing. Oh, sorry, I meant to take nothing. I'll go to 10 and I'll take nothing. I'll take nothing. I'll take nothing. As you can see, I will do this a million times. I'll do this a billion times even. I'll do this endlessly. Because as long as I keep taking nothing, I will have my 10 left and I can take nothing until eternity. Okay. So what we then do is say, okay, 10 divided by 0 is therefore 10 divided by 0 is me trying to take 10 and seeing how many times I can do that. And since I'm only done when there's nothing left, and we still have what? We still have 10 left all the time. So we'll keep taking what? We'll do this forever and still have something left. So we try and say, okay, let's come closer to home and say, let's have only 1. Okay, we go to that 1 and we say, okay, we are going to take, I'm going to take nothing 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. As long as I keep taking nothing, that 1 will still be there. So 1 divide by 0. I've tried to take, what call this? I've tried to take zeros from 1 and I could keep taking nothing until kingdom comes. So again, 1 divided by 0 is going to be infinite. We can take this an infinite number of times and we'll still be left with what? With our 1. So now, the 0 divided by 0 is a little complex. The 0 divided by 0 is a little complex. It needs some abstract thinking. Now we have nothing there. I'll put it in a circle. There's nothing in that circle. Now I go to that circle and I take nothing. I took nothing from the circle. I still have nothing left. I go to that, take nothing. I take nothing. I take nothing. I take nothing. I take. But my 0 is still there. So I'm still taking and my 0 is still there. My still taking and my 0 is still there. So again, I will we'll soon find out that we can keep doing this until kingdom comes. Therefore, 0 divided by what? 0 divided by 0 is what? It is infinite. So as you can see here, I do not like this and that are specific cases where they actually highlight that. As you can see, dividing by 0 means trying to take 0. Whatever you're taking from will remain as is. So you can keep doing that and doing that forever. So therefore, you have to remember, when you are dividing by 0, it's basically what? Our answer is always going to be infinite. I need that to be clarified. Now then, let's do some other examples. Let's go and take, all right, that my pen is fine. Let's go and take, let's say I have a number. Probably they'll give you numbers in other bases. Remember, when they give you numbers in other bases, you have to what? You have to convert to binary, because we are doing binary arithmetic. So if they say do it in base 2, whatever they've given you, we've done this already. Whatever base they've given you, you have to convert your answer to what? To base 2 to perform your calculations in what? In binary. So now let's take examples. Let's say I'm going to say a number like, let's say that's my 32. That's 32 and 16. No 8. No 4. A 2 and a 1. That's 2. So this here is what? 32 plus 16, which is 48. This is 51. Now I say 51. I divide 51 by what? By 3. So I divide 51 by, so let's say my question says divide 51 by 3, but do it in what? In binary. You they have to convert. We've shown you how to do what? How to do this already. So you convert your 51 into binary, and then you convert your 3 into binary, and what? And that will be 1 1. It is best to what? To always try and do this in what? To try and do this in in what call this, to try and do this in the in the long division, okay, because we are going to divide 51 by things, so it's going to be what, 110011 base 2 divided by what. So the conversion part, you must not forget, it could have been other bases. So remember, as long as I given other bases, we know now that we've got what, we've got the shortcut method for base 16 and base 8. So you could do that unless you're restricted, in which case you have to what, you have to go via the long route of first converting to base 10. Now let's take that example, and we know it's going to be long division. We've said already. While we're working with it here, is it necessary to put the little 2? It gets a little crampy, so it gets a little squeezed up. I wouldn't really mind not seeing the 2 there for the what, for the thing, as long as our final answer is going to show. As long as we show it way initially, and then we're going to show it in the final answer, I don't think really we need to be bothering with this, because it's going to get a little bit, sometimes it gets a little crowded. So to avoid the crowding, we would basically in this space only probably ignore the 2, but depends, doesn't really matter. So what are we doing here? We're going to say 11 there is 0. Okay, I'm putting the 0 for a specific what call this reason. I'll come back to it. I'll say 0 times that is 0. So why would I bother? I go and say, okay, let's try 11 into 11. Remember, with the multiplication, we started from what? We started from this side and we went that way. With division, you will see you are going in the opposite direction. So we go to the next bit and you say, can 11, not 11, sorry, 1 1. I said 11. Yo. Big problem. I said 1 1. 1 1 into 1 1 will give us, obviously they're equal, so it's going to be a 1. 1 times 1 1 is going to be 1 1. And we subtract. What do? We get our answer there. Our answer is what? This is too long. I don't like that. Okay, let me just remove it. And then this is going to be 0 because they are equal. Now we bring in this 0 and we say, can this, a new part of the number, can that go in there? No. We bring in the next one. Can that go in there? No. We what? We bring in the next one. Can that go in there? No. We say, can you bring in another one? Yes. Can that go in there? They are the same in fact, so it will go in 1 time, and therefore we multiply, and that is 1 1. What do? We say subtract, and therefore our answer is 0. When we've got 0 here and there's nothing else to bring down there, then we know that this here is our answer. So we can put our little 2 there. So this is basically how binary division is going to be done. Let's say we had something like the same, but it was 1100, 11 base 2 divided by, let's say, 1, base 2. If you remember from the decimal, we always try to avoid to have a comma in the what you call the quotient. We'll always try to clean that up. What do? We multiply that by what looks like a 10 over 10 to, in binary, in decimal we'll do that, we'll multiply by 10 over 10, but then this is what? This is binary. So the nice thing about it is that what looks like a 10, which is in fact 2 in binary, this is our base. Remember, 2 is our base. The 2 does the same job that the 10 in what does in what? Does the same job in binary that the 10 does in what? In decimal. So let's prove this. We know that 73,2 times 10 is going to be what? I don't have to prove this. We know this. 732. What has the 10 done there? It has moved the comma one place to the what? To the right. Let's say it was 73,2 divided by 10. What would happen? You will see that this comma will move one place to the left, and our answer will be 7,32. Now what I'm saying is, if we then take, we've done multiplication already. If we took 1, I think we've explained this multiplication. We're doing this for emphasis now. 1100, 11. This is base 2, and we multiply by 10 base 2. You will see that this will be our placeholder. That will be a 1. That will be, what am I doing? I'm repeating the whole multiplication. We just did this in the previous exercise. So this is a 1, that is a 0, that is a 0, that is a 1, that is a 1. Then we say, okay, there's nothing else. So what do? We count the total number of decimal places between the what? Multiply and multiplicand. What do you have? We've got 1, 2 only, 1, 2, and there is our comma. If you look, this is 1, 1, 0, 0, 1, 1, 0, 0, but the comma has moved one place to the right. It has moved past that one, and then we've got comma 1. That is what we have there. So all that the 2 has done the same job that the 2 that the 10 did in base 10. Our 10 in base 10 moved our comma what? Moved our comma one place to the right. So same happened here. You can rest assured that when you divide by 10, it's also gonna what? If we divide this by 10, it's gonna move our comma what? One place to the left. Let's do our what? Let's take our 2 and divide it into 1, 1, 0, 0, comma 1, 1. Base what? Base 2. Let's say it can't go in there. We go to the next one. It's 1, 1, so it's bigger. It will go in once. Every time with binary, the nice thing is it always goes in once or not at all. So when you multiply, it's 1, 0. We subtract, it gives us a 1. Now when you look at this now, we bring down the 0. It's the same, so it will give us a 1. 1 times that, it will be, so we subtract, and it gives us a 0. We bring in that 0, and what does it do? It says 0. Now, there is our comma, so we place our comma, we bring down the 1, and obviously that is what? It can't go in. Okay? And then what do? We say, bring that one down. What happens now is that this is going to go in once. Let me move this up a little bit. Move this up a bit. And then when we multiply, it will be 1, 0. 1, 0. When you subtract, that's a 1. Remember that this here, when you add zeros in front of the what? Of a number with commas, it will not change the value. So we can bring that one down. We bring that one down there, it will be 0. So these two are the same, it will go in once, and then this is what? This will be, let me possibly move this again up. Okay, so this will be, oh, we're subtracting there, I forgot the line. We're subtracting, now that was the one we multiply, it's a what? 1, 0, and when you do that, it's now done. So what you see here, your comma was what? Was you had, look at the number, forget the 0 before the number is basically redundant. So if we remove the redundant one, what then we have got it. We started off with 1, 1, 0, 0, 1, 1. Remember this side we were multiplying. Okay, 1, 1, 0, 0, 1, 1. It's still 1, 1, 0, 0, 1, 1. What has happened is that there were 2 decimal places, now there are 3. Now there are 3. What has happened? The comma seems to have jumped over that 1. So sorry, that 0. So what we have, the comma has jumped over that 0. So the same way that your 10 moves your comma when you're dividing, moves your comma to the left, your 1, 0, your 2 has moved your comma to what? To the left as well. So the 2 does to base 2 what a 10 does to, or the 2 does to numbers in base 2 what a 10 does to numbers in what? In base 10. When you what? When you are multiplying or dividing. Okay, and dividing. All right, so obviously it follows the 8 will do the same for what? For the base 8 numbers. The 16 will do the same for the what? For the base 16 numbers. So now that we have this, probably now I can open a new page. Open a new page. Now that we've got this understanding, we can then go and say, let's do other examples of division. No, I had that. Let me go back to that situation there. We want to do our division, this division here. This division here. I want to, hopefully, maybe I can copy. I want to see if I can copy this and then come and see if I can. Is it possible for me to paste this on this side? I've not done this before, so it's something that I'm trying. Let's go and see. It's not happening. So what I'll do is, okay, I'll just have to remember it's 1, 1, 0, 0. Okay, it was 1, 1, 0, 0, 1, 1. Okay. What we'll do is I will go and say 1 1. We failed to copy and paste. 1 1 0 0 1 1 paste 2. We had a comma somewhere. We had a comma there. We divide that by 0. Oh no, it was 1 comma 1, right? It was 1 comma 1. So this is divide by 1 comma 1. So what we know now is we don't want a comma in the what, in the quotient, so what, or the divider. What we then do is we say if we multiply a number by 1, we have not changed its value. So what we'll do is we'll multiply by 1 in such a fashion that we will get rid of the we'll get rid of the comma in the what, in the not the quotient. I've been saying the quotient, in the denominator, in the quotient, in the denominator or the divider. What we then do, we come here, we say, okay, this is an overall value of 1, so we've not changed this ratio. We then say that 1 0 will then move the comma once to the right. That 1 0 will move the comma once to the right. So we basically have I'm on a pen, okay, it's fine. So we basically have 1 1 0 0 1 comma 1 being divided by 1 1. So now we don't have what, we don't have commas in the what, in the denominator, not quotient. Quotient is the final answer in the denominator. So what we're going to do now, we're going to say 1 1 into 1 1 0 0 1 comma 1. Then we say, okay, that there, it cannot, we go to the next one, they are the same, so it's a 1 times that, it's 1 1, we subtract, and that is a what, that is a 0. We bring this 0 down, we try here, no, so we put a 0. What do? We bring the next one down, we try there, it's a 0. So we try the next one, we bring that one down, we try on the 1, that one 1 cannot go into a 1, 3 cannot go into 1, so this is also a 0. Our comma stays in this position. So what we then do, we still get, if we multiply, we get 0, so it's pointless. We bring the next one, they are the same, is 1 1 into 1 1, so it will be 1. Then when we multiply, it's 1 1, we subtract, and we've got 0. We've got nothing else to, that is of use, that we can bring down. We could bring down a 0, but you don't change anything, this will stay 0, so we are fine. Anyway, we'll be adding zeros on after the what, after a number, after the comma, so there will be what, there will be no change in value. So this here is therefore our answer. This is how we divide in what, this is how we divide in and this is an example with commas. I did the same example without commas. Now I'm doing the same example with what, with commas. So now if you look at the what, if you look at the denominator and you look at the answer, both of them have got one decimal place. And if you look at what the dividend, it had 2 decimal places. Remember, when you multiply that and that, you're supposed to get the dividend. And remember, when you multiply, the total number of what decimal places in the answer is the same as what, the divider and what, and the divider, okay, the divider and the what, and the quotient, they've got 2 between them, so that's why the dividend is 2, which means it's what, it's consistent. So we are happy. I don't know if I have to do one last example. If I have to do one last example, probably I'll make it easier. I'll take it probably, let's say 1 0 0 1, which we know is a 9. Divide that 9 by, let's say should I make it a 9? Let me make it a 15 actually. Let me make it a 15 because 9 is going to be too simple. Let me make it a 15. And you say divide that by what? By 101, which we know is a what? Which we know is a 5. So it's 5, 101 and 111. We know it's 5 into 15. We expect an answer that says 3. 5 cannot go into 1, therefore it's 0. I go to the next one. 5 cannot go into 3. I say 0. I go to the third one. 5 cannot go into what? Can go into 7. Therefore this is 1. 1 times 5 is going to be 5. We subtract. 1 minus 1 is a 0. 1 minus 0 is a 1. These are the same, so further it's no longer useful. We bring down the next one. Now when you divide, they're identical, so it's going to be a 1. 1 times that is going to be 101. When you subtract, it's a 0. There's nothing of consequence that we can bring down further. So we've got a 0, so we are done. We know the 1 is equal to 3. 5 times 3 is equal to 15, and therefore we are very happy. Now what I would like to do, just like we did with the multiplier, I would like now to look at how the computer does this. Okay, so what will we do? We'll then go and say, okay, let me have another page and say I will have another page and say how computer divides, and then we'll take you through the steps. What do we want to do? We want to load a dividend. Step 1, our dividend, let's take 1 1 0 0 1 1 that we've done already. Okay, this is our dividend. Then we say, okay, step 2, what are we dividing by? We are dividing by 1 1 1. Let's say we divide by 1 1. Okay, so what do? We say, okay, we look at step 1. This is just loading our dividend. This does loading our divider. Step 2, we say, if we look here, can this first 2, is that number bigger than this? Can this number be subtracted from that one there? Answer is yes. Okay, step 3 is, can 2 be subtracted? Subtracted from the, I will simply make it simple and say the bits above it. Ne? If yes, load 1 as MSD. If no, load 0. Okay, so the answer is yes. So our MSD is what? Can you subtract? Then subtract. I should have said and subtract. So when you subtract, I'll probably bring my step 3 here. And say, let me remove that part and probably bring my step 3, then say, after I subtract, this is 0 0. I bring the rest of the number down. I'm subtracting the whole number. 0 0 1 1. I'm subtracting, but I'm subtracting from the what? From the right towards the left. From the left towards the right. I'm subtracting from the left towards the right. I'm working from the MSD towards the LSD. Remember, with the multiplication, we were working from the LSD towards the MSD. With division, we are going in the opposite direction. So now, what you then say, after we do this, we say, after subtracting, is this at the same level? I don't think so. So I'll bring it down. So I will bring this down to make it the same level. What I'll then do is, I'll then say, after you subtract, I'm still not happy. So what I'll do is, I'll bring it further down. And I will bring it further down to line up with the instruction. Okay. I've subtracted. So what I then do is, I then say, okay, step 4, I will say shift our answer, which is 3, 1 bit to the left. So what do? we shift this to the left, but in this case here, our what? Our MSD is lost, and we are left with this comes. Oh, I'm at 4. I'm actually at 4. I'm rushing things here. I'm trying to avoid a very long video, so this one is lost. We have this one coming there, and the rest following. Okay, now number 5, we ask, can the divider, can 2, which is the divider, be subtracted? Yes is again 1. Yes equals to 1. No equals to 0. Okay, so in this case the answer is no. Shift again to that. Now we're shifting 4, the contents of 4, 1 bit to the left. Okay, so what happens is that with step 6 here, number 4 shifts 1 bit to the left, so that one is lost. We are left with 0, 0. This 0 comes there, that 0 becomes the second digit. This MSD is lost, that 0 becomes the MSD, that becomes the second, that one becomes the third bit, and that one becomes the fourth. Question then is number 7. You repeat this question. Can, I think I remember how to copy and paste. I think I remember how to copy and paste. Now, no, okay, let me say, all right, control, copy, control, paste, and then I move one of them. No, I didn't do it. All right, so I don't remember it. I thought I'd done it before. It didn't work, but I'm confused why. But anyway, I have to write. I'm trying to avoid having to write this. I'm tired of writing the same thing. Can, I was gonna change the 2. Can, now that we've shifted, can our divider, in this case this is 3, no, 5. Again is 2, but anyway, let me say 2. Yes, 2. Why? Because this is our divider. Let's say can 2 be, which is our divider, subtracted. I already said it above. Can 2 be subtracted? Yes is equal to 1. No is equal to 0. So our answer there was no. So this was 0 is second digit. We forgot that part. Now, can 2 be subtracted? So we have our divider. Can it be subtracted? The answer is no. Shift 6, 1 bit. So in this case, in the case of what? In the case of multiplier, we're using a right shift register. In this case, we're using a what? A left shift register. So this is going to be 1 bit to the left. We're using a left shift in the case of a. So now, no, and another 0 is loaded. Third digit of the quotient of the answer. All right, so this What do we do? No, we shift 6. So we've got 0, 1, 1. This is shifted, that 0 is lost. The MSD is lost. This 0 becomes the MSD 1 and 1. So then you say, after, then you ask again, can 2, our divider, be subtracted from 6, from 8, be subtracted? Yes is again 1. Okay, and no is 0. Now the answer is, can you subtract the what call this, the divider? Remember, this is the dividend. I didn't list this. So you load the dividend, you load the divider. So 2 is always our divider. So can the divider be subtracted? Answer is number 10 here. The answer is, when you try to subtract, no, the answer is no. So what do we do? We shift. What we've done there is shift 8 to, remember, this was what? This is, okay, this is 8. We're now shifting to what? This is as our, we're using what? The left shift register. So you shift 8 1 bit. I'm forgetting 1 bit to the left. Every time we can't do that, what we do, we know we couldn't subtract, so we add a 4th digit. Is 4th digit. Every time we can't subtract, we load a 0 to the answer. So this is our 4th digit. All right. Now we ask 11 is saying, can 2 be subtracted? Yes. Oh, okay. These are questions. You see? All right. So this is a question. Right. So can 2 be subtracted? Question. If yes, we load 1. If no, we load 0. So what happens then now is that, in this case, the answer is yes. So what do? Okay, can 2 be subtracted? All right. This was, okay, this here is for moving, from shifting. So we actually subtract now. Our answer is going to be a 12. So when you subtract, if the answer is yes, what do? We subtract. Ne? Yes, subtract, load 1 as 5th digit. Now, so we subtract, and we've got 0. Now, there is, with our divider had 2 bits. We've got 2 bits, so we are done because we've got 0. We've got 0. So our answer therefore is what? Therefore, answer is, the most significant digit was the first time we tried. The first time we tried, what happened? Our answer was 1, and subtract. We didn't write this down, did we? We said load, but we didn't load. We just said subtract, load. After you subtract successfully, you load a 1. If yes, load 1. We already said it here. Okay, we already said it here. Okay. If yes, load. So we actually said if yes. This was just say what you would do, or that. So we didn't actually do the loading. So load 1 as MSD. So we've got there, our answer is 1 The second bit was a 0. The third bit was a 0. The fourth bit was a what? Was a 0. And the final bit was a 1. And our answer is in what? Remember, this is equivalent to 1 times 2 to the power of 0, this 1, plus 1 times 2 to the power of 0, 1, 2, 3, 4. Okay, this is 1 and 16, this is 17. And of course, we remember that this was what? This was our 51 divided by 3, and of course our answer is 17, and we are happy. This is basically how the computer will do the job. This is we're just describing the process. So I hope you understood, and I hope you're happy. We've done all the computations. I'm going to come back though and do subtraction again, but this time I'm going to show how we use complements, and also how we use sign bits. Till we meet again to do that. Ciao. I hope this was fun.